today, guys. If you have not turned in Review 19, do that now. If you've not turned in the pi and decimal color sheet where we are adding and subtracting decimal numbers, do that now. Go ahead and put this video on pause and submit that to me, and then come on back. And when we finish today's lesson, I need you to watch our two-part video. This is part 1, as it says right here, where we're going to go over lesson 6L98. Then our part 2 video is going to be over 6L99, and that is what you're going to complete after you watch video number 2, part 2. And so we've got 10 total problems. They are due tonight by 8 p.m. And make sure you get that done, all right? Let's get rolling with this. Oh, by the way, did you notice no power-ups this week? So let me just give you this. See, we could be doing this. So that's the color sheet that was due. That's the color sheet that was due. And this is the power-up sheet that we're not going to do this week. Yay! And so now let's go ahead and take a look at lesson 6L98. We've got 2 examples, as you can see right here. And it says sum of the angle measures and triangles. Oh, sum of the angle measures of triangles and quadrilaterals. Some of you may remember we did talk about this before. When we think of rectangles, remember rectangles, what makes them special is that they are quadrilaterals that are parallelograms because they have 2 pairs of parallel sides. But what makes them special as a rectangle is they have 4 rectangles, right angles, which means 90 plus 90 plus 90 plus 90 equals 360. So when we've got a rectangle, or any quadrilateral, all quadrilaterals, whether they be parallelograms, trapezoids, or trapeziums, all 4 of their angles will always add up to 360 degrees. Whoops, that here went away. And so whenever we're adding up quadrilaterals, the corners, the angles always add up to 360. And the measures of triangles, if you remember correctly, when we were finding the area of a parallelogram, the area of a parallelogram was base times height. Okay, that's finding the area of a parallelogram, which you could even do that with a rectangle because, whoa, another hair falling out. Whoops. Hold on, there we go. Okay, so we've got any parallelogram, whether it be a rectangle, what's it called, a rhombus or a square. They've all got a base and a height, and then and so with the rectangle, we usually call it the length and the width, and then with the square, we have the 2 sides. But what we can do when we have a triangle, we found out that the area of a triangle, if you remember with me here, area equals base times height divided by 2, because all triangles are half of a parallelogram. So we could cut that in half, and when we cut 360 degrees in half, it equals, 180 degrees. That's right. And so when we are finding the sum of the angle measures of triangles and quadrilaterals, we just got to remember that all quadrilaterals add up to 360 degrees and all triangles add up to 180 degrees. So let's take a look at this example. Well, actually, these are the notes that you will be getting when we come back. These little guys, I'm not going to send those to you to have you copy and put in later, but that's what we've got here, where it just shows you basically what I just showed you, that triangles always add up to 180 degrees. And so one way that you could find that missing angle is you could add up the 2 that they give to you, this 40, this 60, and that equals 120, and so 180 minus 120 is 80 degrees, so that's finding that missing angle. And then, like I said, the sum of the interior angles of all quadrilaterals is 360 degrees, so if they give you 3 of the 4 angles, you would put those in parentheses, add them up. 120 plus 80 is 200, plus another 80 is 280, so 360 minus 280 is 80 degrees. So again, the whole point of this lesson is to find those missing angles. So here we go, example number 1. It says, and please write this in your math notebook, EX number 1, what is the measure of angle A? And you know what, as I'm doing this, I have the feeling that we've already done this before, but this is good practice. So let's take a look. So maybe you're just looking at yours right now and draw this triangle, which is triangle ABC. And they're telling us that this angle is 60 degrees and this angle is 70 degrees. And so we want to find out, what is this angle A? Now, if you remember what I just said, what is the total amount of degrees in a triangle, it's 180 degrees. So we're going to say 180 degrees minus, then in parentheses, 70 degrees plus 60 degrees. And then we're going to solve that. And using our PEMDAS, our order of operations, we're going to solve what's in the parentheses first. So we're going to say 180 degrees minus 130 degrees. And then 180 degrees minus 130 degrees is 50 degrees. Da-da-da! I hope so. Let's see. Am I right? They said this. Oh, they said angle A plus 60 plus 70 is 180, which you could do that too. But let's see. But they did say the answer is 50 degrees. Yes, got it right. All right, next one is example number 2, where we're going to find what is the measure of angle T in the quadrilateral QRST. So EX2. And go ahead and draw this weirdie. Looks like a trapezium. Yep, a trapezium, which is, of course, a, that didn't look like a trapezium. Mine looked like more like a trapezoid. Okay, so QRST, and they tell us that this is 80 degrees, this is 80 degrees, and this is 110 degrees. And so we want to find out what is that missing angle T. And so find out what that is. Remember the 4 angles of a quadrilateral add up to 360 degrees, because 90 plus 90 plus 90 plus 90 is 360 degrees. So we're going to say 360 degrees minus 110 degrees plus 80 degrees plus 80 degrees. And then we're going to solve, again, using PEMDAS, 360 degrees minus, I like to say 160. 160 plus 110 is 270 degrees. And then we're going to, wow, that doesn't look like a 90-degree angle, but I guess it is. Must be. So this one right here is a 90-degree angle. So 360 minus 270 is 90 degrees. So the measure of angle T is 90 degrees. Again, let's see if Mrs. Terry's right. She may have made a mistake. Let's see. Nope, 90 degrees. All right, so those were the 2 examples for 6L98. And let's see. Oh, that's the next thing, and we're going to come to that in just a moment. I'll see you in a moment.